Hello students, so we were doing image formation by plane mirror in our earlier lecture. Now what we will do is we will study about extended objects, image formation by plane mirror. Now as you see on the screen, first I would like to cover the clock problem. Now usually what type of question you get is, suppose there is a clock and it's showing 3 a.m. or 3 p.m. whatever it is, and then we have to get an image of that. So if we draw the image, we know whatever is the distance between the mirror and this end of this needle, the same distance from here to here will remain from here to here, and this will remain as such. So if you make it this here, and of course this and this will remain the same, so you will see that it is 9 a.m. in this clock. So this type of question can be tweaked and then can be asked. Now I have to tell you a trick or an alternative way of doing. For example, if they give you a question saying that the watch here or the this watch here is showing 4 hour 45 minutes and 15 seconds, and then you have to draw that here. Now one of the manual ways can be, I can draw one more needle and then take a do it by the normal course, the way we do earlier questions as well. But there is a quick trick. What you do is you just write 12 here, which is 12 means 12 hours 00 minutes and 00 seconds. This can also be written as 11 hours 59 minutes and 60 seconds. Correct? What you do is you just subtract this by this. So if you subtract, you will get this. So if I have to say what will be the time in the image clock of this, it is 7 hour 14 minutes and 45 seconds. This question usually they ask in exam, so just pay attention to it, because sometimes they can give you 2-3 marks or 1 mark question. Okay, now I'm doing one more question. Just look at it. It's already done in this sheet of paper and I'm re-recording because of some issues with the audio. A boy of height h wants to see his full image in a plane mirror. Find the minimum length of mirror required. Okay, again I repeat. So the boy is of height h, correct, and he wants to see his full image in a plane mirror, right? He wants to know what is the minimum length of mirror required for getting his full image. When he says full image, means from head to toe. Okay, so let me do one thing. I have drawn a straight line. This is head, feet and eye of the boy. Now what I have done is I have drawn a plane mirror of equal height as the boy here. Now with the normal thing, I can draw the image of the boy, and this this distance, this and this will remain constant, this and this will remain constant, this and this will remain constant. So I have drawn it here. That you already know how to draw. We have already practiced in earlier questions. Now what you do is, see, remember you have to, in this mirror, you need to have a look of entire from head to feet. Okay, so now for this what I am doing is this is somewhere where the eye of the image is, correct. So what I am doing is I am joining the head because it is the peak. See, when I say peak, if I talk of a mirror which can show the image of a boy, then for the entire image, what are the two peaks? Two peaks are head and feet of the boy. So what I am doing is I am first trying to attach head with the image eye. So let's say I is B, then image is B dash. So I am trying to connect. Okay, very good. Now, or you can say the other, let me go the other way around. What I'm doing is, here is the eye, and this is the head of the boy. So I'm just attaching it with the, I am just connecting it with a line. But as you know, beyond the mirror, it is just a reflection. Beyond a mirror, it's just a reflection. So it is a virtual image. So after the mirror, I've just put in dot 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 here. And then after here, the rays are actually, this way. Correct? Okay. So let me reiterate the whole thing again so that you are well versed. So what I've done is, I've connected I to the image through a line. Through a line. Now beyond the mirror, this line is in a dated, because it is not, it's an illusion, right? But in illusion you will see a straight line. So I'm just attaching. So beyond mirror, I put it in dots. Okay. Now after that, you just connect it with the head, because we need to have the entire glance of the head as well, right? So the ray will come from head, correct, and then hit it here in the mirror, and then will go to the eye. But we will feel that head is here, because it's giving, this is a plane mirror, and it will give a virtual image. Okay. Now we have already done for the head. Now we are doing the same thing for the feet. So I, we are just connecting I with the image of the feet here. Straight line. Once it reaches the mirror, it takes, it's connected this way. Correct? Okay. So, or you can say, image or ray from the feet goes this way and it reaches the eye. So these are the two peaks, extreme positions in the boy height we have taken, because we have to include the entire boy. He should not miss anything. Now after drawing this, what we will do is, first we will see this triangle. Which triangle? B, A dash, B dash. Now in this triangle, I have drawn it here. B, A dash, B dash. In this triangle, you will, and this is the mirror. So this is mirror. So if you'll see in this, we know this distance and this distance I have denoted by X, and I put it here. Now these both distances are same, X and X. So both the triangles, this and the bigger one, this B, P, Q, and bigger one, B, A dash, B dash, are similar triangle. In the similar triangle, as per the property of similar triangle, we will have this side divided by this side, which is PQ. I have written it here. These are corresponding sides, will be equal to B, B dash, B, B dash, this whole sides divided by BQ, BQ. This is as per the similar triangle. Or, but BB dash, BB dash is 2x, so I have written it 2x. BQ I have written x, so x cancels. So I can say A dash B dash is 2PQ. Okay. Now this is first thing, or I have put it as equation number 2. Now go to the triangle, this triangle, this triangle. This triangle is B, B dash C. Now in the triangle B, B dash C, you will see, you can prove in the similar fashion, exactly the same, that B dash C dash is equal to 2QR. 2. So this is twice of this. Why? This distance remains the same, right? And we can compare in this big triangle and in this small triangle, both are similar, and then we have done it in the same fashion, and we will get this. Now if you look at this diagram, you will see that anything beyond P, anything this mirror beyond P actually is useless. We can cut it off because at P we are including the head and there is nothing beyond the head. So this portion is not required. Number one. In the case of feet, feet are shown here at R. So this portion is removable. We can throw this portion which is under R. Okay. So the only portion of mirror to show the entire this object's image is PR. Now, got it? Very good. So for the entire image of boy, you need only PR portion of mirror. But PR is nothing but PQ plus QR. PQ plus QR. Correct? PR is nothing but PQ and QR. PQ is half of this and QR is half of this B dash C dash. So the whole from here to here is half of A dash to C dash, which is the height of the boy. So that means if I club equation number 1 and 2, then I can say PR is equal to 1/2, PR is equal to 1/2 of A dash C dash, and A dash actually is the image of A and C dash is the image of C. So AC is equal to height of boy and this is also height of boy. Correct? So it means for getting the entire image from A dash to C dash, we just need PR portion of mirror, which is half of this. Half of this. That is what I have written, but A dash C dash is equal to height of a boy. So the length of mirror should be half of at least. Okay, so that means to see our entire image in a plane mirror, we need to have at least half of our height length of the mirror. Otherwise, we might not see from head to feet. Okay, very good.